Hello, I'm Jim Wall with the Gilson Engineering Columbus, Ohio office. Thanks for joining me on this brief video to review the setup and calibration of the ECD Intelligent S80 Universal Sensor and the T80 Universal Transmitter. ECD has traditionally made all their measurements with two basic types of probes. First, we have the traditional S10 sensor, an immersion style sensor used for all different types of measurements. We have a compression fitting. This one I happen to have here has a 3/4 inch NPT process connection. It may be installed onto the S10 probe so that the 3/4 inch NPT threads face the process. And we use this in an immersion style so that if I were to go across a flume or a weir and have a 3/4 inch connection, I can lower the probe down into the flow stream. In those applications where I have a deeper tank, we can take that compression fitting and reverse it so that the threads face upward. We can position that on the sensor 3 inches up from the bottom, as on the very face of the sensor, internally we have a temperature sensor. Temperature is important to many measurements, including pH. We would then connect the 3/4 inch NPT, fish the leads up through a piece of pipe of a length that would be long enough to lower our S10 sensor so that it is always wetted. The second style of sensor offered from ECD is an insertable valve retraction probe. We have traditionally called this the S17. The S17 is made of a piece of stainless steel tubing, internally amplified, and the electrode on the front, just the same as the S10. But with this assembly, we allow you to extract the sensor, shut a ball valve, sealing you off from the process, allowing you to remove the sensor and accomplish your calibration. Reinsert the sensor, open the ball valve, and you're back in business. In the Intelligence series, we now call the immersion sensor an S80. Here I have an S80 with a pH front end. I also have an S80 with a conductivity front end. It's not only the front end, it's the internal amplifier. The biggest innovation from ECD with the Intelligence series is that the zero and span, the millivolts corresponding to 0, 7 pH, and span, either 4 or 10 buffer, are stored in the sensor. When I connect with the transmitter, the T80, it digitally reads what type of sensor it is and then uploads from the sensor the zero and span values. Upon power up of the T80 intelligent transmitter, it's looking for a sensor. Once a sensor is connected, it interrogates the sensor for the type and span of measurement. I've just connected a conductivity sensor. And you see on the display, I show the type of measurement, conductivity. I show it in microsiemens. I show the percentage of output and the temperature. On the right-hand side, I show a status of the internal relays. The T80 can be purchased as a 2-wire loop-powered unit. It can be also line-powered. When I say line-powered, it could be AC or DC, and can have relays. When I do buy a line-powered unit, I do get the backlighting on the display. It is an LCD display, which is very good in high-intensity light areas, as in outdoors. There's also a sun shield available for the T80. I'm going to go ahead and disconnect the conductivity transmitter and reconnect a pH. It interrogates the sensor and finds that it is a pH probe. Now, on the front of the display, I have 4 keys, and they become soft keys. Hitting any one of those keys twice in succession puts it into the configuration menu. After depressing the button twice, I have definitions for each of the 4 soft keys. For our intents and purposes, we're going to cover the calibration. By depressing the far left-hand key for calibration, it's going to ask me if this is a new sensor. The reason it asks this is because the S80 stores 3 calibrations. If you happen to find out that you had a bad buffer solution or something along those lines, you could always revert to one of the prior calibrations. In our particular case, this probe is not brand new, so I'm going to answer no. If I answer yes, it wipes out all 3 calibrations and would accept the one that I'm going to perform as the one and only. The T80 simply asked me to place the sensor in one of my calibration solutions. I'm placing that in 7 buffer. As you can see, the T80 starts to interrogate the transmitter, reading the millivolt value coming off of the pH electrode. It's going to wait for stabilization, and once it's satisfied that it is stable, the T80 thinks it's as close to one of the standard calibration solutions of 7. Once stabilization has been satisfied, it's going to come up and say this is 6.99 pH, corrected. Do we accept it? If this was a 7 pH buffer, 6.99 is correct. If it's not, if there was another buffer solution you're using and you wanted to correct, it allows you to make a manual entry. For our intents and purposes here, we're going to accept it as yes. With the first calibration point completed, I'm going to continue on to cal number 2. For cal number 2, I'm going to use a pH buffer solution of 4. Once again, the transmitter looks for stabilization in the reading. An ideal slope on a pH transmitter is 59.1 millivolts per pH count. Right below the pH reading, you also get a raw millivolt value. Once the stabilization is completed, we'll return back to the operate mode. The screen does give me an approximate slope as well. As you can see, it's 54 minus 54.12 millivolts. 7 pH always should you approximately 0 millivolts. You would get an offset with degradation over time of the reference half cell that's exposed to the process. In our particular case, we see that we still have an acceptable slope of 54.12. That's acceptable up to approximately 50 millivolts. With the first calibration point completed, I'm going to continue on to cal number 2. For cal number 2, I'm going to use a pH buffer solution of 4. Once again, the transmitter looks for stabilization in the reading. An ideal slope on a pH transmitter is 59.1 millivolts per pH count. Right below the pH reading, you also get a raw millivolt value. Once the stabilization is completed, we'll return back to the operate mode. The screen does give me an approximate slope as well. As you can see, mine is 54.12 millivolts. 7 pH showed you approximately 0 millivolts. You would get an offset with degradation over time of the reference half cell that's exposed to the process. In our particular case, we see that we still have an acceptable slope of 54.12. That's acceptable up to approximately 50 millivolts. Now that we've completed a calibration, I want to show you a couple nice features of the S80/T80 combo that make it a true winner. On the display, with the soft keys, once again I'm going to hit any one of the four twice in succession. And instead of going into the calibration, I'm going to go into the simulate. With simulate, this allows me to fire my relays if I wish. Relay 1, 2, or 3, and force it. This way I can ensure that my chemical feed is going to activate as I expect it to. Pushing the back key, I can come over and simulate my 4 to 20, ensuring that my PLC is scaled the same as my pH transmitter in the field, a very common error. Also, I have system simulate, and this allows me to ramp my analog output if I wish. Another nice feature is the ability of configuring the transmitter. I can adjust the LCD display. I can adjust the output so that I get the 4 to 20 over the desired range. I can also adjust the serial settings. This unit has a 4 to 20 milliamp output as standard. It has a second 4 to 20 milliamp output as an option. That second 4 to 20 milliamp can be assigned to temperature if a single probe is used. This unit is also available in a dual channel. While the S80 sensors are available in a wired unit, the capability of automatic calibration, as I've shown you, in conjunction with the quick disconnect on the back end, either a straight or right angled, makes it a true winner and makes it easy for you to utilize in the field with the ability to do your calibrations back in the lab. For additional information on the S80 and T80, please contact your local Gilson office.